and move to the Excel file and read together with you which is the problem. A micropipette is set on the nominal value 500 microliters. The actual volume is measured by weighting the volume of water taken by the pipette. Calculate the confidence interval of the mean with a 95% confidence level. So the operator performed 10 measurements. You see, this is the subscript I that indicates general measurement. And the operator weighted the mass and obtained 10 values measured in grams. We suppose that the error on the scale is negligible, and we want to evaluate only the statistical errors. We want to apply these simple equations. So we want the confidence interval, generically written as average value or central value, plus minus the absolute error. Delta is called absolute error. And the formula that we have learned this morning is this one. We must calculate the average of the 10 values and write plus minus t. We want to calculate t depending on the significance, the risk that we accept, and the degrees of freedom, that is 9 in this case, and multiply by s divided by the square root of n. And s, that is the standard deviation of the sample. Here the sample is the statistical sample. A sample containing 10 measurements. Okay? The possible results of weighting that volume are infinite, but we have performed 10 measurements. So we have a sample, a statistical sample of the statistical population. The statistical population is are all the infinite values that we could read by weighting that volume. Okay? So we have a statistical sample containing 10 measurements, and the standard deviation is the formula that we have learned this morning. Okay? Of course, we don't need to apply the formula. We will look for functions, ready functions in Excel. Now I want to obtain from these mass, values of mass, the volume. So I must divide the mass, measured in grams, by the density, measured in grams per milliliters. And I will obtain the volume in milliliters. The formulas are already typed behind these cells, but I will obtain it together with you. So if you want, you can learn something about Excel. I repeat, I will never ask you to create Excel files. Okay? This exercise is only to deeply understand what we are doing. Okay, to obtain this column, the D column, what I have done. Please type with me if you want. I type equal. If I click on Excel on a cell and type equal, means I want to insert a formula. Also plus makes the same, plus or equal as usual. And then I write the operations to be done. I click on the cell B7, which means take the value that you are reading in B7. Then I type divided by, the slash over the number 7. This means divide by. And then I click on the cell containing the density, C7. Or I can type equals C7 divided by the C7. Okay, this is the formula. Now I don't want to type again the formula in the cells below. I want to copy the formula. But when you tell to Excel to copy a formula, the program will change the names of the cells. Let me do an experiment. I click on this cell and I click or visualize the formula bar to see which is the formula. Then I click copy or Ctrl C. If I click below, in the cell below, and I make paste, what happens? Click on the new cell, D19, and look what the software has done. What was D7 has become D8, this is okay, but also C7 has become C8. I don't want this. I want that all the cells in the B columns are divided by the same cell, C7. This is told to the software by, now go back to the previous cell, click inside the formula bar. You must type $2 before and after the letter. So, $C, $7. Okay. This means if I copy this formula in the cell below, you change only the B, not the C. Okay? This means that the cell C7 is blocked. Now I can copy, so copy, click below, paste, okay. So copy the formula, click below, paste, and now in the new cell B19, I read B8 divided by C7. This is correct. Okay? So dollars means if I change place in the worksheet, keep C7 the same and change on the B. Okay? This is what I did in the cell D7. You see, in the click on the cell D7, and you see that I had typed B7 divided by blocked C7, $C, $7. And I copied. There is another way to copy quickly. You go on this border, down on the right, until you see a cross. You click left on the mouse and go down. This means copy the formula in the column. If you need help, I will come in your position. Do you need some help? I can make back. Okay, now I delete these numbers, they are not useful. So I obtained 10 values in milliliters, but I want microliters. So what did I do? I typed a formula telling take the number in D7 and divide by 1000. So what I did here, equal, click on D7, divided by 1000, enter. Oh, sorry, multiplied. Oh, sorry. From milliliters to microliters, I multiplied by 1000. Okay? So I say take the cell D7, multiply by the fixed number 100, and then I copy it below with the cross. It is easy. This is what I did in the column E. Okay, so these are the values in microliters. Have a look to the fact that when I have directly measured the mass, I could visualize 4 digits. Okay? But since I divide by 1.003, the division gives many digits. And later we will discuss which of these digits have significant value, are significant from the experimental point of view. And I will teach you how to establish which digits are significant. But simply have a look that I started with 4 digits, and here I have a lot, because there is the division. Okay? In the cell F7, I simply typed the known value, the reference value. I expect 500. And then I calculated the average. How did I do? Type it together with me. Equal average. You see that the software proposes you several functions. The first one is good. You can do double click on this or directly type a round bracket, open round bracket. And you see that the software is telling to you the format of the input, what does it ask to you. And it asks to you to tell in which cells the input values are present. And I answer this way. I make a click on the left on cell E7, and I go down until I see that the software has written, sorry, I lose the control, E7 column E16. This means take the numbers that you see between these cells in this column. This is a vector, a series of 10 values in a column. This is called a vector. I could also type a semicolon if there were other values to pick up, but there are not, so it is finished. To finish a function, I always have to close the round bracket. Okay? I type enter and I see the result. Okay? Is it easy for you? If you have a look on the cell G7, click inside the formula bar, you see that I have typed take the numbers from E7 to E E106. Why did I type this? Because the void cells are ignored. So if I type other values, they will be calculated, and I don't need to retype the function. Okay? Let us make an example. I write here 500, and the calculation has been updated. Okay? I delete 500, and it goes back to the right calculation. It is a quick way to prepare a worksheet and use it for several possibilities of the number of measurements. Okay? Now I need to calculate the standard deviation of these 10 values.
So, Professor, just a doubt, but these 10 measures are already averaged, right?
No, they are single measurements.
So why we use the confidence intervals for the mean?
Because we want to answer to this problem. Okay, now I perform 10 measurements and I find an interval. If 100 operators repeat the same experiment, I want to predict in which interval their means will fall.
Okay, so it is something we can do, even if we have a single measurement. Okay.
But starting from single measurements, I can evaluate also the confidence interval of the mean.
Okay, okay.
And I do it by dividing S by the square root of the mass.
Okay.
So this S is this, standard deviation of the sample. The standard deviation is always referred to single measurement.
Okay.
So S is the standard deviation. S over square root of n is the standard deviation of the mean. To obtain this value, if I do not remember the name of the function, I can use this tool. I move with the mouse to this icon, insert function, and click. So a dialog box is open, and if I do not remember the name, I can type here a question. Standard deviation. And go. There are several functions, and for each of them there is an explanation. If you click on the right one, SDDAD, you see the explanation below. This function is available. Okay, sorry. This was the name of the function in the previous versions of Excel. The new one is this, sddiv.s. Standard deviation of the sample, and below you read estimates standard deviation based on a sample, ignores logical values and text in the sample. Okay, so this is the right function. You can click on OK, and again here you type the vector where the values are. So click on E7, go below, up to E16, or type E7, column E16. And then click on OK. Again, I had typed the same function. If you click on H7 and click in the formula bar, I preferred to make as an input the vector E7, column E106, to be allowed to insert other values And so I obtain a timely updating. Okay? We can go on? Now I want to type the number and number of measurement. I could type 10. But if I insert other measurement here, I want the software to update the number. So I have used the function count. Count how many cells are filled with numbers. Let us introduce it together. Equal count, open bracket round or double click, and then I can type B7 column B106, close the round bracket. Lowercase and uppercase are not important. I click enter and it is counting. If here I add a value, 0.5, it becomes 11. So it is updated automatically. So we have n. Degrees of freedom. This is simple because it is the number of measurements performed, 10, minus how many parameters do I want to calculate? 1, the average. So I type equal, click on I7, type -1, enter. Then significance is typed, of course, because I must choose which number put there. And I have typed 0.05. I have the dot as decimal separator. Maybe you have the comma, I don't know. In English it is dot. It is not important in Excel, but it is important if you copy some, if you import some Excel numbers in other software. So it is useful to obtain the decimals with the dot. To do that, I can teach to you. Go down here in search and search the function intl.cpl. It is the control panel. It is existing in some menu, but it is very difficult to find, so I type directly the function that makes me format the numbers. Okay? So it is intl.cpl. You find it here, control panel item. Does it work? Okay. Start recording. Okay. Once you have typed intl.cpl, you run, and this is the dialog box. And then you click on additional settings, and then decimal symbol, you type dot, grouping symbol, comma. And then apply OK 2 times. I have already applied the dot. If you have the comma, it will change. Once typed here, decimal symbol dot, digit group symbol, comma, click on apply OK, and then again apply OK. So this is dot, this is comma, dot in the first box, comma in the third, apply OK, and the comma becomes dot as decimals. Okay? You need help? Somebody needs help? Can I go on?
Yes.
Okay. Now we have to calculate the t. The subscript tab means that it is taken from the tables, the statistical tables. And the function is called, let us start together, equal t dot I and v. You see, when you have typed t.inv, you have two functions. The first one is the old name in the previous version of Excel. The new name specifies that there are two tables. So you type dot to t. So this means please calculate t in the case of two tables. Open the bracket. It is asking to you the probability, but this means significance. And it is significance written as a fraction of 1. So it is the number typed in cell K7, O.05. Okay? And then my software has semicolon, sometimes they use comma, I don't know in yours. And then degrees of freedom, they are in the cell J7. Click on J7, close the bracket round, and enter. You see that the number that I have obtained has a different number of digits. But this is only a question of visualization, because the two numbers in the memory have the same number of digits, and you can observe them in this way. Click on L7. If you go up and find the icon increase decimal, you can add the other digits. There are a lot of digits in the memory, you see? It is not useful to visualize all these. I visualize only, I format the number with a lower number of digits. But in the memory, the number is present with all its digits. So in general, I represented the t with 3 digits because it is easier to read the worksheet. Then I calculate delta V of the mean. Delta V of the mean, you see, if you compare this formula with this one, it is T multiplied S divided by square root of n. So we must introduce this formula, okay? This is delta S. Click on M8, type equal. Now we must click on the cell containing T, click on L7 or type L7, multiplied by S. S is contained in H7. Click on H7 or type H7, divided by square root is a function. If you don't remember, you can go in the insert function, but it is easy. It is sqrt, square root, sqrt. Open the bracket. Now click on the cell containing the number of measurement, that is E7, and close the round bracket. And this is the result. Now we must discuss this number and digits it has. This is an uncertainty. And this number is telling to me, pay attention, the error falls on the units of microliters. Okay? Because the error is 6 dot some numbers microliters. Means that I am making an error on the unities of microliters. Is it clear? But if it is true, this digit 4 does not make sense because it is below the order of magnitude of the error. It is the same as the scale that you have at home. Your scale measures down 1 gram. If you weight the water several times and divide by the density, you obtain some numbers that have the grams, but also the 10 to the minus 1 grams, 10 to the minus 2 grams, and so on. But the digits that are below 1 gram of your scale that do not make sense because they are below the capability of the scale to measure. And this is the same situation. If it is true that my error falls on the order of magnitude of unities of microliters, I cannot say nothing about the decimals of microliters. They do not make experimental sense. They are there because they come from a calculation. But the only number having significance is the 6. So what did I do? I copied this number in another cell and formatted it correctly. That is with only one digit. So I copied here, if you click on K11, you see equal M7, so it is copied there. And then, this is the number with all the digits, and then I cleared the digits below the order of magnitude of the error. And the right way of visualizing the error is this one. Only one significant digit, the first. Now,
always, or just in this case due to the...
Always.
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 Right.
And later we will do an exercise on other examples to well understand what I mean. But I have formatted the error with one significant digit. Okay? I have taken only the first visualized digit. But if you look at the average volume that is calculated in G7, you see we have 409 times 8 units, and then we have decimals of microliters. If the error is falling on the units, the following digits do not make sense. So the correct format of the final result is visualizing in the average value, visualizing only the digits which have order of magnitude equal with respect to the error or higher. This is the definition of significant digits. So I have obtained 499 plus minus 6. I will go back I will explain again significant digits, but now we want to understand the meaning of this. Sorry, I have moved this formula. Okay. So let us interpret this result. This result is a numerical interval that is starting from 493 and goes to 505. Okay? Do you agree? Okay, these are the limits, the boundaries of this interval. Okay? And the significance is 5%. So, I predict that if 100 operators perform each of them 10 measurements of the same volume, of the same pipette with the same procedure, and each of these 100 operators obtains his or her average value, I predict that 95 of these average values will fall between 493 and 505. But I predict the risk that 5 of those operators will find their average values of 10 measurements below 493 or higher than 505. This is my prediction. My prediction is based on 10 measurements. So I performed 10 single measurements, I calculated an average value, and I have given the confidence interval where a new average of a further 10 measurements will fall with 95% confidence level. This is the meaning of my result. Okay?
So you must do exactly the same number.
Exactly. The same number with the same pipette, the same water, the same temperature, with all the conditions must be the same. Okay? Of course, what I am doing is a middle reasoning, because I do not have 100 operators to test. This is a prediction. Okay? And my measurement will be of good quality if the confidence interval of the mean is narrow and the confidence level is high, or the risk is low. Okay? Now we want to understand something about significant digits. Now move to the second sheet called the significant digits. You see that the Excel file is organized in several sheets. The ones written in lower cases is my example, and the others written in upper cases are exercises for you. If you want to try it by yourself, and we have time up to 4 o'clock, okay? I have almost already finished, so you will have about 30 minutes to try by yourself to make exercises similar to the ones that I have explained. Okay, move to the second sheet, significant digits, and have a look. These are some possible results. Have a look to the first one. In this case, the operator obtained as average value 2.342, but the error was 0.04321. This number is telling to me your error falls on 10 to the minus 2 here. So the order of magnitude of your error is 0.04. This is equivalent to formatting this number in scientific mode. So follow me and do the same. Click on C2, click right on the mouse, then go to the command format cells. On the menu number, choose scientific and you read 4.32 E minus O2. This means 4.32 multiplied by 10 to the minus 2. And we have to tell the software, please visualize the first number that is called the matrix 4.32. Please format this number without decimals. Like that. So you have to visualize your result as a natural number multiplied 10 to some exponent. Okay? So the correct formatting is this. 4 multiplied 10 to the minus 2. So I have formatted the error with only one significant digit. That is this. A natural number multiplied by an exponent of 10, a power of 10. In this writing, this is the order of magnitude of the error, 10 to the minus 2. And this tells to me that only the digits that are order of magnitude equal or higher with respect to 10 to the minus 2 will have an experimental meaning. They will be significant. So, of course, it is easier to write this like that, 0.05, but it is the same. This writing and this writing are the same thing. Simply, I'm telling to you that if you use the scientific format, you will never be wrong in formatting an error. All the errors should be formatted in that way. A natural number multiplied a power of 10. So we can format all of these numbers in one time. Select all. Select all these numbers together with me. Click right. Format cells, menu number, scientific, no decimal places in the first number. And then OK. And these are the correct way of formatting an error. Only one significant digit, that is the multiplicative part of the number. Okay? So let us take this example. 4 multiplied 10 to the minus 0 means 4 units. Okay? Now, let us make a discussion together. This number 4 is the order of magnitude 10 to the 2. It is 10 to 1, sorry. They are tens. Okay? And this is higher than units. So this is significant. This 4 is significant. The number 5 has the same order of magnitude of the error, because it is unit. 8 is the order of magnitude 10 to the minus 1. It is lower than the order of magnitude of the error. So this number 8 does not make sense. And the result will be 46 plus minus 4. Okay?
So that's the reason why we remove the 2 from the first example.
Yeah. And from the second example, the example was this number, 45.896, etc., becomes 46. Because it is rounded to the order of magnitude of the error. Now, without looking this height, let us format together these numbers. Let us start from this one. Line 6. The order of magnitude of the error is 10 to the minus 9. Okay? Okay?
Yes.
In the average value, this digit 1 is in the order of magnitude of 10 to the minus 6. That is higher than the error. So this number 1 is significant. This number 7 is in the order of magnitude of 10 to the minus 7, which is higher than 10 to the minus 9. So this number 7 is significant. What about the number 9? 10 to the minus 8, significant. Number 8, 10 to the minus 9, it is the last significant. The following are not. So I will do this, decrease decimals. And this is the correct result. Is it clear for you? So in this case, line 6, the average value has been given with how many significant digits? 1, 2, 3, 4. 4. The first 4 digits are significant, the following are not. Do you want to try with this? This could be a number of atoms or molecules in a mole. Okay? Molarity. So the error is 10 to the 21, very big number. Okay? They are thousands of billions, very big number. So have a look to this. Tell me, this number 6 is significant?
Yes.
Yes, why?
It is 10 to the power 23 higher than the other.
Okay. The number 8?
Yes.
To the power 22. The number 9?
Yes.
The last. How many significant digits could I give to the average value?
3.
3. Now try with this. Line 8. The error is on the order of magnitude 10 to the power minus 2. Okay? So, is this number 4 significant?
Yes.
Yes, but it is the last. Because 7 is 10 to the minus 3. So in this case, I have only one significant digit, that is this number, 5. The zeros that I read here are written to account for the order of magnitude. To be simpler, I can format it again in a decimal, in a scientific format. And this is the result. 0.05 plus minus 0.05.
But we always start with the error that should have one significant digit.
Exactly. We should format the error with one significant digit, which means that written in decimal in a scientific format, the multiplicative part is a natural number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are natural numbers. In order to explain again this concept, I have prepared for you this PowerPoint presentation. Replicate direct measurement, significant digit. In the numerical result of an experimental measurement are significant all the digits having order of magnitude equal or higher than the order of magnitude of the error. And the format is this: a natural number multiplied a power of 10, and the power of 10 is the order of magnitude of the error. This means one significant digit means this format: a natural number, a number without decimals, multiplied a power of 10. Okay? There are some particular cases. Look at this. In this case, the error are units. I will format it in a simpler way so it is easier. Okay? The error is 2 units. Okay? But the average value is lower than units. I should have to write like this: 0 plus minus 2. But if I write this, I have no idea of the order of magnitude of the average value. In this case, I leave only one significant digit also in the average value. So I keep idea of what was the order of magnitude of the average value, only in this case. This case means that the result is 0. The result, for instance, the 0 of temperature, it is 0. Okay? And in this case, it is the same. I can copy the format. The error is 1, and the average value is below units. So I leave only one significant digit also here, and I will write 0.6 plus minus 1. Now you have about 30 minutes. I advise you to start from this significant digit and try to format, and then move to other examples. This is a case where the operator performed 15 measurements of the density of ethanol. And we ask you to write the confidence interval of the mean for these 15 values. So try, if you want, to calculate by yourself, and I will follow your work.